Hello and welcome to Beyond Earth. I'm really glad you found your way here tonight. Settling into this quiet moment as the world around you begins to slow down and the gentle darkness wraps itself like a soft blanket around the edges of your day. I'm so glad you're here, in this space we've carved out together, where we can let our minds wander beyond the familiar boundaries of our daily lives and drift into the vast, mysterious theatre of the cosmos that unfolds silently above us every single night. Tonight, as you rest wherever you are in this world, I want you to imagine stepping outside into the cool evening air, feeling that gentle transition from the warmth of indoor spaces to the crisp embrace of the night, and slowly, very slowly, lifting your gaze upward toward that familiar silver companion that has watched over our planet for billions of years. There it hangs, the moon, that ancient sentinel that has been humanity's most constant companion, casting its ethereal light across oceans and continents, through the rise and fall of countless civilizations, through the birth and death of species we can barely imagine, always there, always present, always maintaining its perfect dance with Earth in the cosmic ballet that keeps our world in balance. But what if, in some distant future, or alternate reality, something went terribly wrong with this celestial partnership that has endured for so long that we take it entirely for granted? What if the invisible threads of gravity that hold the moon in its eternal orbit around our planet suddenly began to unravel, causing our silver guardian to spiral inward on a collision course that would reshape not just the geography of our world, but the very nature of existence itself? This is the story we'll explore together tonight, a journey that will take us through the gentle catastrophe that would unfold if the moon, our faithful companion, were to fall from the heavens and reunite with the Earth from which it may have originally been born so many eons ago. Oh, and if you're enjoying these stories, I'd really appreciate a like or subscribe. Super curious where you're all listening from. So, drop a comment with your location and what time it is there. Alright, let's head back to this extraordinary tale that begins not with violence or sudden destruction, but with the subtle, almost imperceptible changes that would mark the beginning of the end of the world as we know it. The moon, that luminous disk that has inspired countless poets and dreamers throughout human history, is far more than just a beautiful ornament hanging in our night sky, far more than the romantic backdrop for lovers' whispers, or the mystical influence that ancient cultures believed controlled the tides of human emotion. Our moon is, in the most literal sense, the architect of life on Earth as we know it, the invisible hand that reaches across the void of space to gently tug at our oceans, creating the rhythmic pulse of tides that may have been essential to the very emergence of life from the primordial seas billions of years ago. Imagine, if you will, our planet as it existed in those early days, a young and restless world where the moon hung much closer to Earth than it does today, perhaps appearing 3 or 4 times larger in the sky, casting shadows so sharp and light so brilliant that the landscape would have been painted in stark contrasts of silver and black. In those ancient times, the moon's gravitational embrace was so much stronger that it pulled at Earth's oceans with tremendous force, creating tides that could rise and fall by hundreds of feet, vast walls of water that swept across continents in regular, predictable cycles, carrying with them the chemical ingredients and energy patterns that would eventually give birth to the first stirrings of life. As eons passed and the cosmic dance between Earth and Moon gradually slowed, our silver companion began its long, slow journey outward, settling into the more distant orbit we know today, approximately 239, 0 miles away from our planet's surface. This gradual separation was not a loss but a gift, a cosmic fine-tuning that allowed life on Earth to flourish in the gentler tidal environment we experience today, where ocean levels rise and fall by mere feet rather than hundreds, creating the stable coastal ecosystems that have nurtured so much of the biodiversity we see around us. But our moon's influence extends far beyond the ebb and flow of tides, reaching deep into the very core of what makes Earth habitable, touching everything from the length of our days to the stability of our seasons. Without the moon's gravitational influence, Earth would spin much faster on its axis, creating days that might last only 6 or 8 hours instead of the familiar 24-hour cycle that governs the rhythm of life as we know it. More dramatically still, without the moon's steadying influence, our planet would wobble chaotically as it orbits the sun, causing wild, unpredictable changes in climate that would make the stable seasonal patterns we depend on utterly impossible. The moon serves as a cosmic gyroscope, holding Earth's rotational axis steady at an angle that gives us the gentle, predictable progression of seasons that allows life to plan and prepare, to migrate and hibernate, to plant and harvest in cycles that have remained essentially unchanged for millions of years. Without this stabilizing influence, Earth might experience ice ages that last for centuries, followed by periods of scorching heat that turn the polar regions into deserts, climate shifts so extreme and unpredictable that complex life forms would have little chance to adapt and evolve into the magnificent diversity we see today. So when we speak of the moon falling to Earth, we are not just imagining a spectacular collision between two celestial bodies, though that collision would indeed be spectacular beyond anything our imaginations can fully grasp. We are contemplating the unraveling of a partnership so fundamental to the nature of life on our planet that its disruption would transform Earth into something entirely alien. A world where the very concepts of day and night, season and tide, stability and predictability would lose all meaning in the cosmic chaos that would follow. The story of what would happen if the moon fell to Earth begins not with the moment of impact, but with the long, slow spiral that would precede it, a gradual descent that might take months or even years to complete, during which the inhabitants of Earth would witness changes so profound and beautiful and terrifying that they would mark the end of one chapter in our planet's history and the violent beginning of something entirely new. As the moon began its inward journey, drawn by whatever cosmic force or circumstance had disrupted its stable orbit, the first changes would be subtle, noticed perhaps only by the most careful observers of the night sky. Night by night, the moon would appear slightly larger, slightly brighter, its familiar face growing more detailed and dramatic as the distance between Earth and its companion gradually decreased. The craters and mountains and ancient lava flows that have remained largely invisible to the naked eye for all of human history would slowly emerge into clarity, transforming the smooth, peaceful disk we know into a complex, detailed world hanging ever closer above our heads. But it would not be long before these subtle visual changes gave way to effects that would be impossible to ignore. As the moon's increasing gravitational influence began to assert itself with growing intensity, the tides, those gentle twice-daily rhythms that have pulsed through Earth's oceans for billions of years, would begin to surge with unprecedented power, rising higher and higher with each passing day, transforming familiar coastlines into alien landscapes of rushing water and exposed seabed, creating tidal ranges that might eventually stretch for miles inland, turning coastal cities into temporary islands that emerge from the sea, only to be swallowed again hours later. As the moon drew closer still, its gravitational pull would begin to affect not just the oceans, but the very crust of the Earth itself, causing the solid ground beneath our feet to rise and fall in great, slow waves, as if the planet were breathing with deep, measured breaths that could be felt across entire continents. Mountains would flex, and valleys would shift as the familiar solidity of land gave way to something more fluid, more responsive to the cosmic forces playing out in the heavens above. And through all of these changes, through the growing chaos and uncertainty that would mark the moon's final approach, there would be moments of almost unbearable beauty. Nights, when the moon would hang so large and brilliant in the sky that its light would be bright enough to read by, to cast shadows sharp enough to seem almost solid, to paint the landscape in silver tones so vivid that they would seem more real than the familiar colours of daylight. The animals would be among the first to sense that something fundamental had changed in the cosmic order that has governed life on Earth for so many millions of years. Migratory birds, whose internal compasses have relied on magnetic fields and celestial navigation for countless generations, would begin to show signs of confusion and distress, their ancient flight patterns disrupted by the changing gravitational environment. Ocean creatures, from the smallest plankton to the largest whales, would find their behaviour patterns shifting as the familiar rhythm of tides gave way to something far more chaotic and unpredictable. Trees and plants, those silent witnesses to the passage of seasons and the cycling of days and nights, would begin to show stress as the changing gravitational environment affected everything from the flow of nutrients through their root systems to the timing of their flowering and fruiting cycles. The very biology of life on Earth evolved over billions of years to function within the specific environmental parameters created by the Earth-Moon system, would find itself challenged to adapt to conditions unlike anything in the planet's long history. Yet, even as the world prepared for transformation, even as the signs of impending change multiplied with each passing day, there would remain something almost peaceful about the moon's approach, something gentle and inevitable that would distinguish this cosmic event from the sudden, violent asteroid impacts or volcanic eruptions that have marked other great transitions in Earth's history. The moon's fall would unfold with a kind of cosmic grace, a slow-motion catastrophe that would give Earth's inhabitants time to witness and perhaps even appreciate the awesome forces at work in the universe around them. This is where our journey begins tonight, at the edge of a transformation so complete and fundamental that it would mark not just the end of the world as we know it, but the birth of something entirely new, something that would carry within it both the memory of what Earth once was and the seeds of what it might become. So settle back into this quiet moment, let your breathing slow and deepen, and prepare to accompany me on a journey through space and time, through the gentle catastrophe that would reshape our world if the moon, our faithful companion, were to fall from the heavens and return to the Earth from which it came so very long ago. In the beginning, the changes would whisper rather than shout, arriving so gently that most of the world would continue its daily routines without sensing that the fundamental architecture of reality was beginning to shift beneath their feet. The first astronomers to notice would be those who spend their nights in quiet communion with the heavens, the dedicated observers who know the moon's face as intimately as they know the faces of their closest friends, people who have memorized every crater and shadow, every subtle variation in the lunar surface that marks the passage of months and seasons across the celestial sphere that has hung unchanged in our skies for all of recorded human history. These careful watchers of the night would be the first to observe that something almost imperceptible had begun to alter the moon's familiar appearance, a subtle enlargement that might initially be dismissed as atmospheric distortion, or perhaps a trick of tired eyes straining too long through telescope eyepieces. Night after night, they would return to their instruments with growing curiosity and mounting concern, taking measurements and comparing observations, slowly building the evidence that would eventually force them to confront an impossible truth that their rational minds would resist, even as their careful data demanded acceptance. The moon, that most reliable of celestial companions, had begun to deviate from the orbital path it had followed for billions of years, slipping inward toward Earth with such gradual precision that weeks might pass before the change became undeniable, and months more before the implications became clear to anyone beyond the small community of dedicated skywatchers who track such cosmic minutiae. But once the truth became established, once the measurements were verified and the calculations confirmed, the scientific community would face the staggering realization that they were witnessing the beginning of an event that would reshape everything they thought they understood about the stability of the solar system and the predictable nature of planetary motion. As word of the moon's changing orbit began to spread through observatories and universities around the world, teams of astronomers and physicists would work frantically to understand what force could possibly be drawing our satellite toward Earth. What cosmic influence could be powerful enough to overcome the gravitational equilibrium that has kept the Earth-Moon system stable for so many millions of years? The explanations they would develop might range from the scientifically plausible to the wildly speculative, encompassing everything from the gradual influence of some previously undetected massive object in the outer solar system, to the possibility that the moon's internal structure had somehow changed in ways that altered its gravitational relationship with Earth. But regardless of the underlying cause, the effects of the moon's inward spiral would become increasingly impossible to ignore as the weeks turned into months, and the subtle changes in the lunar appearance gave way to transformations that would be visible to anyone who bothered to look up at the night sky. The moon would begin to loom larger and more imposing with each passing week, its familiar features becoming more detailed and dramatic, its light growing brighter and more intense, casting shadows that seemed sharper and more defined than anything in living memory. Children would be among the first to notice these changes in their everyday lives, commenting to their parents that the moon looked different, bigger somehow, more present in the sky than they remembered from previous months. Parents might initially dismiss such observations as the product of active young imaginations, but gradually, even the most skeptical adults would begin to acknowledge that something fundamental had changed about the lunar presence that governs our nights, something that touched not just the appearance of the moon but the very quality of moonlight itself, the way it fell across familiar landscapes and transformed ordinary scenes into something more mysterious and otherworldly. The first practical effects of the moon's changing orbit would manifest in the behavior of Earth's oceans, those vast bodies of water that have danced to the moon's gravitational rhythm for so long that the twice-daily pulse of tides has become one of the most predictable and reliable phenomena on our planet. Marine biologists and oceanographers would be among the first scientists to document the subtle but unmistakable changes beginning to affect coastal ecosystems around the world, as tidal ranges that had remained essentially constant for centuries began to show signs of amplification and irregularity. Initially, these changes might manifest as variations so slight that they would be noticed only by those who make their living from the sea, the fishermen and harbour masters and coastal engineers who depend on precise tidal predictions for their daily work. A high tide that runs 6 inches higher than predicted a low tide that drops slightly further than expected, variations that might seem insignificant to casual observers, but would represent profound departures from the mathematical precision with which tidal forces have operated throughout recorded history. As the moon drew closer to Earth, these subtle variations would gradually intensify into changes that no one could ignore. Tidal surges that would strain seawalls and flood coastal roads, low tides that would expose seafloor areas that had remained underwater for decades or even centuries. Harbours that had been carefully designed to accommodate the predictable rise and fall of normal tides would find themselves challenged by water levels that exceeded all previous records, while coastal wetlands and estuaries would experience flooding and exposure patterns unlike anything in the ecological memory of the plants and animals that call these transitional environments home. The creatures of the sea would sense these changes long before human instruments could measure them with precision, their ancient biological rhythms disrupted by gravitational influences that their evolutionary heritage had never prepared them to encounter. Countless species of marine life time their reproduction, migration, and feeding behaviors to coincide with specific tidal conditions, relying on internal clocks calibrated over millions of years to the predictable ebb and flow of lunar influence. As these patterns began to shift and intensify, the carefully orchestrated ballet of oceanic life would find itself performing to music that no longer followed familiar rhythms. Sea turtles, those ancient mariners who have navigated Earth's oceans for over 100 million years, would be among the first to show signs of confusion, as the changing tidal patterns disrupted the complex environmental cues they rely on for navigation and nesting. Female turtles, arriving at traditional nesting beaches, according to instincts refined over countless generations, would find themselves struggling to locate suitable sites as familiar shorelines transformed under the influence of unprecedented tidal ranges that could expose or submerge nesting areas at unexpected times. Coral reefs, those magnificent underwater cities that depend on precise water levels and circulation patterns for their survival, would begin to experience stress as the changing tides altered the delicate balance of nutrients and water flow that sustains these complex ecosystems. Some coral communities might find themselves exposed to air during extreme low tides, while others could be buried under sediment stirred up by the increasingly powerful tidal currents that would accompany the moon's closer approach. But the effects of the moon's changing orbit would extend far beyond the boundaries of Earth's oceans, reaching into the atmosphere itself and beginning to influence weather patterns in ways that would initially seem random and chaotic, but would gradually reveal themselves as part of a larger transformation affecting the entire planet. The moon's gravitational influence, while most dramatically visible in its effects on liquid water, also extends to the gases that make up our atmosphere, creating subtle tides in the air itself that most people never notice, but which play important roles in weather formation and atmospheric circulation. As the moon drew closer to Earth, these atmospheric tides would begin to intensify, creating pressure variations and wind patterns that would interact with existing weather systems in complex and unpredictable ways. Meteorologists around the world would begin to notice that their traditional forecasting models, based on centuries of observational data and decades of computer modeling, were becoming less reliable, as atmospheric conditions began to deviate from historical patterns in ways that seemed to defy explanation. Storm systems might intensify more rapidly than predicted, or dissipate unexpectedly when conditions suggested they should continue to strengthen. High and low pressure systems could linger in regions where they would normally move through quickly, or race across continents with unusual speed, creating weather patterns that would challenge every assumption about atmospheric behavior that scientists had developed over generations of careful study. The jet stream, that river of high-altitude air that plays such a crucial role in determining weather patterns across entire continents, would begin to show signs of instability as the changing gravitational environment affected the delicate balance of forces that keeps this atmospheric current flowing in predictable patterns. Regions that had enjoyed stable, temperate climates for decades might suddenly find themselves experiencing unusual temperature swings, unexpected precipitation patterns, or seasonal changes that arrived weeks earlier or later than historical records would suggest. Agricultural communities around the world would be among the first to feel the practical impacts of these atmospheric changes, as growing seasons that had remained relatively consistent for generations began to shift in ways that challenged traditional farming wisdom. Crops that had been planted according to schedules refined over centuries of experience would find themselves struggling to adapt to temperature and moisture patterns that no longer followed familiar rules, while farmers would watch helplessly as weather systems behaved in ways that seemed to ignore every lesson learned from their ancestors about reading the sky and predicting seasonal changes. Yet, even as these changes began to accumulate and intensify, even as the evidence mounted that something unprecedented was occurring in the cosmic relationship between Earth and Moon, there would remain something almost dreamlike about the early stages of this transformation. Something that would make the entire experience feel less like a natural disaster and more like a gradual awakening into a different kind of reality. The Moon's increasing size and brightness would transform nighttime landscapes into scenes of almost supernatural beauty, painting familiar environments in silver light, so intense and detailed that evening walks would become journeys through worlds that seemed both intimately familiar and utterly alien. Artists and poets would find themselves struggling to capture the ethereal quality of these transformed nights. The way moonlight would seem to penetrate deeper into shadows and reflect more brilliantly from water surfaces, creating visual effects that no previous generation of human beings had ever witnessed. Photographers would discover that their cameras could capture details in moonlit scenes that would have required artificial lighting only months earlier, while painters would find themselves mixing colours and working with contrasts that had no precedent in the artistic traditions they had inherited. Children born during this period of gradual transformation would grow up thinking that this intensified moonlight was normal, that shadows had always been so sharp and nighttime visibility had always been so clear, creating a generation that would carry within their memories a baseline of lunar influence completely different from anything their parents had experienced. These children would be the first humans in Earth's long history to develop their understanding of night and day, light and shadow, under the influence of a moon that was steadily growing larger and more powerful, their developing brains calibrated to a celestial environment that was changing even as they learned to recognize and interpret the world around them. And through all of these changes, through the gradual intensification of tides and the subtle shifting of weather patterns, through the transformation of nighttime beauty and the confusion of creatures whose instincts no longer matched their environment, there would run an undercurrent of anticipation and wonder that would distinguish this cosmic event from any natural disaster humanity had previously experienced. This would not be a sudden catastrophe demanding immediate response, but rather a slow unfolding of forces so vast and fundamental that they would invite contemplation as much as concern, inspiring as much awe as anxiety among those who took the time to truly observe and reflect on what they were witnessing. The moon's fall toward Earth would represent not just a physical transformation, but a profound shift in the human relationship with the cosmos, a reminder that we live within systems of force and motion so immense that our everyday concerns and assumptions about stability and permanence are revealed as beautiful but temporary illusions, patterns that persist only as long as the underlying cosmic architecture continues to support them. As months passed and the moon continued its inexorable journey inward, the subtle changes that had initially whispered of transformation would gradually give way to effects so dramatic and undeniable that even the most casual observers would begin to understand that they were witnessing something unprecedented in the history of human civilization. The moon, now visibly larger than anyone alive had ever seen it, would begin to dominate the night sky with a presence so commanding that it would fundamentally alter the human experience of darkness, transforming familiar nocturnal landscapes into alien territories painted in silver light, so intense that it would seem almost like a second, gentler sun hanging in the heavens above. This intensification of lunar presence would mark the beginning of what scientists and poets alike might come to call the Dance of Destruction, a cosmic choreography in which two ancient partners, Earth and Moon, would begin to move together in patterns increasingly different from the stable, predictable orbit they had maintained for billions of years. Yet, even as this dance led inevitably toward catastrophe, there would be something undeniably beautiful about the way these celestial bodies responded to each other's gravitational influence, something that would inspire as much wonder as terror among those who took the time to truly observe and contemplate the forces at work in the universe around them. The moon's increasing gravitational pull would begin to affect Earth in ways that extended far beyond the obvious changes in tidal patterns and atmospheric behavior, reaching deep into the planet's interior and awakening geological forces that had remained dormant for millennia. The solid crust of our planet, which seems so permanent and unchanging from our human perspective, would begin to flex and deform under the intensifying lunar influence, creating what geologists might describe as solid earth tides, enormous waves of rock and soil that would rise and fall across entire continents with the same regularity that water tides had always followed, but with effects far more dramatic and transformative than anything humanity had previously experienced. These crustal tides would initially manifest as subtle changes in elevation that might be detected only by the most sensitive scientific instruments, variations measured in inches or centimeters that would seem insignificant compared to the massive scale of continental landmasses. But as the moon drew closer and its gravitational influence intensified, these gentle flexing motions would gradually amplify into movements that could be felt by anyone standing on solid ground, creating a sensation that the Earth itself was breathing beneath their feet, rising and falling in slow, rhythmic patterns that would follow the moon's passage across the sky with mathematical precision. Buildings and infrastructure designed to rest on foundations that remained absolutely stable would begin to experience stresses unlike anything their architects and engineers had ever considered, as the very ground beneath major cities started to shift vertically by feet rather than inches with each tidal cycle. Skyscrapers would sway not just from wind and seismic activity, but from the gradual rising and falling of the land itself, creating structural challenges that would test the limits of human engineering and force entire urban populations to confront the reality that even the most fundamental assumptions about planetary stability were no longer reliable. The effects would be particularly dramatic in coastal regions, where the combination of enhanced water tides and solid earth tides would create compound flooding events unlike anything in recorded history. Cities built at sea level would find themselves dealing with tidal ranges that could span dozens of feet, transforming familiar harbours into temporary lakes during high tide periods, then exposing vast expanses of seafloor during the extreme low tides that would follow. Venice, Amsterdam, New Orleans, and countless other communities that had learned to live with the rhythmic rise and fall of normal tides would discover that their carefully engineered flood control systems were utterly inadequate to handle the new reality of lunar influence. But perhaps nowhere would the effects be more visually spectacular than in the great mountain ranges of the world, where the solid earth tides would create scenes that would challenge everything humans thought they understood about the permanence of geological features. Mountain peaks that had stood unchanged for millions of years would begin to rise and fall by measurable amounts with each tidal cycle, creating the surreal spectacle of entire mountain ranges breathing like living organisms, their summits shifting position against the star field in slow, hypnotic patterns that would be visible to anyone with the patience to observe the sky over the course of several hours. The psychological impact of these changes on human populations would be profound and far-reaching, touching not just those who lived in areas directly affected by the enhanced tidal forces, but everyone who depended on the assumption that solid ground provided a foundation of absolute reliability and permanence. The very concept of terra firma, solid earth, would lose its meaning, as people around the world gradually came to understand that their planet was becoming increasingly plastic and responsive to cosmic forces beyond any possibility of human control or influence. Animals, with their deeper connection to natural rhythms and their sensitivity to environmental changes that often exceed human perception, would begin to exhibit increasingly erratic behavior as the familiar patterns that had guided their evolution for millions of years continued to shift and intensify. Migratory birds, already confused by the changing magnetic environment and disrupted seasonal patterns, would begin to show signs of complete disorientation, with some species abandoning their traditional flight paths entirely, while others would attempt to follow routes that no longer matched the environmental cues their navigation systems had evolved to recognize. The great whales, those magnificent ocean wanderers who navigate vast distances using a combination of magnetic sensing, underwater sound channels, and celestial navigation, would find their ancient migration routes disrupted by the changing acoustic environment of increasingly turbulent seas. The enhanced tidal forces would create underwater currents and pressure variations that would alter the sound transmission properties of seawater, effectively scrambling the acoustic highways that whales had used for navigation and communication throughout their evolutionary history. On land, the effects would be equally dramatic, as the changing gravitational environment began to influence everything, from the growth patterns of trees to the behavior of insects, whose life cycles had been calibrated over millions of years, to specific environmental triggers that were no longer arriving at predictable times. Forest ecosystems, those complex communities of plants and animals that depend on precisely timed interactions between hundreds of different species, would begin to show signs of systemic stress, as the fundamental rhythms that coordinated everything from flowering and fruiting cycles to predator-prey relationships gradually fell out of synchronization. Trees, those ancient witnesses to the passage of seasons and the cycling of years, would begin to exhibit growth patterns unlike anything in the fossil record, their root systems struggling to maintain stability in ground that was no longer truly solid, their branches and leaves responding to gravitational influences that pulled and tugged at their cellular structure in ways that had no precedent in their genetic memory. Some trees might lean toward the moon during its closest approach, their normally vertical trunks bending like compass needles toward the massive gravitational influence hanging overhead, while others might show stress responses in their leaf production, flowering, or fruit development as their internal biological clocks struggled to adapt to an environment that was changing faster than evolutionary processes could accommodate. The enhanced moonlight that would accompany the moon's closer approach would create its own set of biological disruptions, as nocturnal creatures found themselves operating in light conditions unlike anything their species had evolved to handle. Owls and other night hunters might struggle to maintain their stealth advantage in an environment where moonlight was bright enough to cast sharp shadows and illuminate details that had always remained hidden in the protected darkness. Night-blooming flowers might alter their opening and closing cycles in response to the intensified lunar illumination, while nocturnal pollinators could find their foraging patterns disrupted by light levels that blurred the traditional boundaries between night and day. But perhaps most profoundly affected would be the countless species of marine life whose reproduction cycles had evolved to coincide with specific phases of the moon. Creatures whose very existence depended on the predictable timing of lunar influences that had remained essentially constant throughout their evolutionary history. Coral spawning events, those magnificent underwater blizzards of reproductive activity that depend on precise lunar timing, would begin to occur at unexpected times, or might fail to happen at all, as the traditional celestial cues became overwhelmed by the moon's increasingly dominant presence. Sea turtles, those ancient mariners whose nesting behaviors had been fine-tuned over 100 million years of evolution, would find themselves increasingly confused by beach environments that were being reshaped with each extreme tidal cycle. Traditional nesting sites might be submerged during what should have been optimal nesting periods, while new temporary beaches might appear and disappear so rapidly that turtle navigation systems calibrated to recognize stable coastal features would be rendered useless. The human response to these accelerating changes would vary dramatically across different cultures and communities, reflecting not just practical concerns about safety and survival, but deeper philosophical and spiritual questions about humanity's place in a universe that was revealing itself to be far less stable and predictable than anyone had previously imagined. Some communities might interpret the moon's approach as a natural phenomenon requiring scientific study and technological response, marshalling their resources to understand and adapt to the changing conditions through engineering solutions and careful observation. Others might see the falling moon as a sign of cosmic significance, a message from the universe that called for spiritual reflection or dramatic changes in human behavior and social organization. Religious leaders and spiritual teachers around the world would struggle to interpret the meaning of an event that seemed to transcend all previous categories of natural disaster or divine intervention, while philosophers and artists would find themselves grappling with questions about the nature of permanence, change, and human agency in a cosmos that was demonstrating its power to reshape the fundamental conditions of existence without regard for human desires or understanding. Scientists working frantically to model and predict the moon's continued descent would find themselves dealing with computational challenges that exceeded the capacity of even the most powerful supercomputers, as the complex interactions between gravitational forces, tidal effects, atmospheric dynamics, and geological responses created a system so chaotic and interdependent that accurate long-term predictions became virtually impossible. Each day would bring new data that would require revisions to existing models, while the accelerating pace of change would make it increasingly difficult to distinguish between short-term fluctuations and fundamental shifts in planetary behavior. International cooperation, normally hampered by political boundaries and competing national interests, would begin to take on unprecedented urgency as the global nature of the crisis became undeniable. No single nation would have the resources or expertise to address challenges that were simultaneously affecting weather patterns, ocean currents, geological stability, and biological systems across every continent and ocean on Earth. Emergency planning committees would struggle to develop response strategies for scenarios that had no historical precedent, while evacuation procedures and disaster relief protocols designed for localized events would prove inadequate for a transformation that was reshaping the entire planet simultaneously. Yet even in the midst of increasing chaos and uncertainty, there would continue to be moments of extraordinary beauty that would remind observers that they were witnessing not just destruction, but a kind of cosmic artistry playing out on a scale so vast that human minds could barely comprehend its full significance. The moon, now appearing several times larger than anyone alive had ever seen it, would transform night photography and astronomical observation into experiences of almost overwhelming visual intensity, while the enhanced tidal forces would create temporary geographical features and water displays that would rival any natural wonder in Earth's long history. Photographers and artists would find themselves documenting landscape changes that occurred not over geological timescales, but within the span of single tidal cycles, capturing images of coastlines that might exist for only a few hours before being transformed again by the next extreme tide. The combination of intensified moonlight and dramatically changing geography would create opportunities for artistic expression that no previous generation of humans had ever encountered. Inspiring works of art that would attempt to capture not just the visual spectacle of planetary transformation, but the complex emotions of wonder, terror, and acceptance that would characterize humanity's response to forces beyond their control or comprehension. And through all of these changes, through the gradual acceleration of effects that would make each week noticeably different from the last, there would remain the underlying rhythm of the cosmic dance itself, the mathematical precision with which two massive bodies continued to respond to each other's gravitational influence, even as their ancient partnership moved toward its inevitable and spectacular conclusion. As our lunar companion continued its slow spiral toward Earth, drawing ever closer with each passing month, we would approach one of the most significant thresholds in planetary science, the invisible boundary in space that represents the point where the gentle gravitational dance between celestial bodies transforms into something far more dramatic and irreversible. This boundary, known to astronomers as the Roche limit, marks the distance at which a large celestial body's gravitational field becomes so powerful that it begins to overcome the internal gravitational forces that hold a smaller orbiting body together, creating conditions that would fundamentally alter the nature of our relationship with the Moon and herald the beginning of the final act in this cosmic drama. The Roche limit, named after the 19th century French astronomer Édouard Roche, who first calculated its mathematical properties, exists at approximately 2.44 times the radius of the larger body, which in Earth's case would place this critical boundary roughly 500 miles above our planet's surface. This invisible sphere surrounding our world represents a kind of cosmic point of no return, beyond which the Moon's structural integrity would begin to fail as Earth's gravitational field started to pull more strongly on the lunar surface, closest to our planet, than on the materials that make up the Moon's far side, creating differential forces that would gradually stretch and deform our satellite in ways that would become increasingly visible to observers on Earth's surface. The approach to this critical distance would mark a transition from the gradual, almost gentle changes we have witnessed in previous chapters to transformations that would be both more rapid and more visually spectacular, as the Moon itself began to show signs of the tremendous gravitational stress that would ultimately lead to its complete disintegration. Long before reaching the Roche limit, careful observers using telescopes would begin to notice subtle changes in the Moon's shape, a gradual elongation that would make our formerly circular companion appear increasingly egg-shaped, with the pointed end always facing toward Earth, as the differential gravitational forces began to pull the lunar mass into what astronomers call a tidal bulge. This deformation would start so gradually that it might be detectable only through careful photographic comparison over periods of weeks or months. But as the Moon drew closer to the critical boundary, the changes would accelerate and intensify until they became visible to the naked eye, transforming the familiar circular disk that had watched over humanity for thousands of years into something strange and almost organic-looking, as if the Moon was slowly stretching like taffy under the influence of forces too powerful for its internal structure to resist indefinitely. The psychological impact of watching our celestial companion visibly change shape would be profound and disturbing for human populations around the world, touching on deep emotional and spiritual connections that cultures throughout history have developed with the Moon's familiar presence. Children who had grown up singing nursery rhymes about the man in the Moon would find themselves looking up at a celestial object that no longer resembled anything in their cultural memory, while adults would struggle to reconcile the distorted appearance of the lunar surface with lifelong assumptions about the permanence and reliability of astronomical objects. As the Moon's distortion became more pronounced, reaching the point where even casual observers could see that something fundamental had changed about its shape, the effects on Earth would intensify correspondingly, creating tidal forces unlike anything in our planet's geological record. The elongated Moon, with its mass redistributed into an egg-like configuration, would create gravitational effects that were no longer symmetrical or predictable, causing tidal patterns that would vary dramatically depending on which portion of the deformed lunar mass was facing Earth at any given time. When the moon's pointed, Earth-facing end passed overhead, tidal forces would reach unprecedented intensity, creating ocean surges that could rise hundreds of feet above normal sea levels, while the gravitational effects on solid ground would become so pronounced that people might actually feel the sensation of their weight changing as they stood beneath the distorted satellite. During these periods of maximum tidal influence, coastal regions around the world would experience flooding events that would make previous tsunamis seem modest by comparison, as walls of water swept inland for dozens or even hundreds of miles, temporarily transforming the geography of entire continents. The solid Earth tides that we explored in previous chapters would reach their own spectacular crescendo during this period, creating geological effects that would be visible from space, as entire mountain ranges rose and fell in slow waves that followed the moon's passage across the sky. Satellite imagery would capture the surreal sight of continental landmasses flexing like living tissue, with changes in elevation so dramatic that they would alter weather patterns and atmospheric circulation in ways that meteorologists would struggle to predict or understand. But perhaps most remarkably, as the moon approached the Roche limit, observers on Earth would begin to witness the early stages of lunar disintegration, a process that would unfold with a kind of terrible beauty that would challenge every assumption about the permanence of celestial objects. The first signs might appear as subtle changes in the moon's surface brightness, areas where the gravitational stress had begun to fracture the lunar crust and expose fresh material beneath the ancient, weathered surface that had remained essentially unchanged for billions of years. These initial fractures would appear as dark lines or patches visible through telescopes, spreading across the lunar surface like a network of cracks in an eggshell, under stress, growing longer and more numerous, with each passing day as the differential gravitational forces continued to pull at the moon's structure with ever-increasing intensity. Amateur astronomers around the world would document these changes with increasing urgency, creating time-lapse photography that would capture the gradual disintegration of humanity's oldest celestial companion in unprecedented detail. As the fracturing process accelerated, pieces of the moon would begin to break away from the main body, starting with small fragments that might appear as tiny bright dots separating from the lunar limb, but gradually growing to include larger chunks of material that would create their own visible trails as they either fell toward Earth or were flung outward into independent orbits around our planet. These lunar fragments, ranging in size from pebbles to mountains, would create the beginnings of a ring system around Earth, a temporary celestial feature that would rival the magnificent rings of Saturn in its visual impact, while serving as a constant reminder of the cosmic forces that were reshaping our corner of the solar system. The formation of Earth's temporary ring system would create some of the most spectacular astronomical displays in human history, as countless fragments of lunar material, each following its own orbital path around our planet, would create meteor showers unlike anything previously witnessed. Night skies would be filled with bright streaks of light as lunar debris burned up in Earth's atmosphere, while larger fragments that survived atmospheric entry would impact the planet's surface, with effects ranging from brilliant fireballs to crater-forming explosions that would be visible from thousands of miles away. During this period, the distinction between night and day would begin to blur as the combination of the moon's intensified brightness, the light reflected from orbiting debris, and the frequent meteor displays would create an almost continuous illumination that would transform the human experience of darkness. Sleep patterns that had evolved over millions of years to coincide with regular cycles of light and darkness would be disrupted on a global scale as biological rhythms struggled to adapt to environmental conditions that had no precedent in Earth's long history. The debris field surrounding Earth would also create practical challenges for human space activities, as satellites and space stations would find themselves navigating through an increasingly cluttered orbital environment filled with chunks of lunar material traveling at tremendous velocities. The International Space Station and other orbital installations would face constant threat from impacts that could range from minor collisions with dust-sized particles to catastrophic encounters with boulder-sized fragments, forcing space agencies to consider evacuation procedures for astronauts who might find themselves stranded in an environment that was becoming increasingly dangerous with each passing day. But even as the moon's disintegration created chaos and uncertainty, there would remain something undeniably magnificent about the process itself. A cosmic spectacle that would inspire artists, poets, and musicians to create works that attempted to capture the complex emotions of witnessing the destruction of something so fundamental to human culture and consciousness. The sight of Earth's rings, visible as bright arcs stretching across the sky from horizon to horizon, would create photographic opportunities unlike anything in human experience, while the constantly changing patterns of light and shadow created by orbiting debris would transform familiar landscapes into alien environments that seemed to belong to some distant planet, rather than the Earth that humanity had always known. Children born during this extraordinary period would grow up in a world where the sky itself was constantly changing, where ring arcs and meteor showers were as normal as sunrise and sunset, where the very concept of a stable, predictable celestial environment would seem as foreign as the idea of a world without electricity or automobiles seems to us today. These children would develop their understanding of astronomy and natural phenomena in an environment that was simultaneously more spectacular and more chaotic than anything previous generations had experienced, creating a cohort of human beings whose relationship with the cosmos would be fundamentally different from that of their parents and grandparents. As the moon continued to break apart, approaching ever closer to the point where the largest remaining fragments would themselves begin to disintegrate under Earth's gravitational influence, the intensity of effects would continue to accelerate, creating a feedback loop in which each stage of lunar destruction would intensify the forces responsible for further disintegration. The approaching climax of this process would be marked by the final approach of the moon's core, the dense central region that had held our satellite together for billions of years, and which would represent the last substantial remnant of the celestial body that had shaped so much of Earth's history and human culture. The core's final descent toward Earth would create gravitational effects that would dwarf everything that had come before. Tidal forces so intense that they would literally reshape the planet's surface, creating new mountain ranges and ocean basins in a matter of hours, while simultaneously destroying geographical features that had existed for millions of years. This would be the prelude to the ultimate confrontation between Earth and the remnants of its ancient companion, a collision that would mark the end of one era in our planet's history and the violent beginning of something entirely new and unprecedented. Yet even as we contemplate these approaching extremes of destruction and transformation, there remains something profoundly moving about the gradual way this cosmic drama would unfold. The mathematical precision with which gravitational forces would work to reshape both Earth and Moon according to laws of physics that operate with the same elegant consistency, whether they are governing the orbit of planets or the fall of leaves from autumn trees, reminding us that we are privileged witnesses to forces and processes that connect our small planet to the grandest scales of cosmic evolution and change. In the final days before impact, as the last substantial remnants of our ancient lunar companions spiraled through their death dance with Earth, the world would find itself suspended in a state of surreal anticipation, caught between the terrible beauty of cosmic forces at work and the dawning realization that life as humanity had known it for thousands of generations was about to end forever. The moon's core, that dense metallic heart that had once held our satellite together through billions of years of cosmic history, would now hang visibly in the sky like a second sun, its surface glowing with the heat generated by tidal forces so intense that they would literally melt rock and metal, creating a celestial furnace that would cast an eerie orange and red light across Earth's surface during what would prove to be the last normal sunsets and sunrises in our planet's long history. The approaching lunar core, no longer spherical but stretched into an elongated teardrop shape by Earth's overwhelming gravitational field, would appear to grow larger with each passing hour, its distorted form dominating the sky in ways that would make previous changes seem subtle by comparison. This final remnant of the moon, perhaps a quarter of its original size but containing much of its original mass concentrated into an incredibly dense package, would create gravitational effects that would reshape not just Earth's surface features but the very atmosphere itself, pulling at the gases that surround our planet with such force that the normal blue of daytime skies would begin to take on strange colours and distortions, as the air itself was stretched and compressed by forces operating on scales that terrestrial physics had never been required to accommodate. During these final hours, the distinction between solid and liquid, between stable and fluid, would begin to lose all meaning, as Earth's crust responded to gravitational stresses that exceeded anything in its geological memory. Mountain ranges that had stood for millions of years would begin to flow like slow rivers of stone, their peaks melting and reforming as the planet's surface became increasingly plastic under the influence of tidal forces so extreme that they would make the earlier solid Earth tides seem gentle by comparison. Volcanoes that had remained dormant for centuries would suddenly roar to life as the changing gravitational environment cracked open the planet's crust and allowed molten rock from deep within Earth's interior to surge toward the surface in eruptions that would make the largest volcanic events in recorded history appear modest by comparison. The oceans, those vast bodies of water that had danced to the moon's gravitational rhythm for so many billions of years, would begin to behave in ways that would challenge every assumption about the behavior of liquid water on a planetary scale. Tidal bulges hundreds or even thousands of feet high would race around the planet's surface, following the overhead passage of the lunar core like massive liquid mountains that would engulf entire continents, before retreating to exposed seafloor that had been underwater for millions of years, creating temporary landscapes that would exist for only hours before being swallowed again by the next tidal surge. These extreme water movements would create their own weather systems, as the friction between moving water and stationary land masses would generate heat and water vapor on scales that would dwarf any hurricane or storm system in Earth's meteorological records. The atmosphere would become filled with steam and moisture lifted from the churning oceans, creating global cloud systems that would wrap the planet in a dense, humid blanket that would trap heat and reflect the strange light cast by the glowing lunar core, transforming Earth's climate into something that would be more reminiscent of the atmospheric conditions on Venus than anything that had existed on our planet since its earliest formation billions of years ago. Wildlife populations around the world would respond to these final environmental changes with behaviors that would seem to reflect an almost mystical understanding that their ancient world was coming to an end. Birds would abandon their normal feeding and nesting activities to gather in vast flocks that would wheel and turn through skies filled with volcanic ash and steam, their movements creating patterns that would seem less like normal animal behavior and more like some kind of collective ritual or farewell ceremony performed on a global scale. Marine mammals would beach themselves in unprecedented numbers, as if choosing to abandon the increasingly chaotic oceans for the relative stability of land that was itself beginning to flow and shift like liquid under the influence of the approaching lunar core. Domestic animals would display signs of extreme agitation and distress, their normally predictable behavior patterns replaced by restlessness and vocalizations that would seem to express emotions and awareness that their human companions might struggle to understand or interpret. Dogs would howl continuously at the distorted moon hanging overhead, while cats would refuse to venture outdoors, hiding in the deepest and most protected spaces they could find, as their instincts warned them of dangers that their evolved behavior patterns had no framework for addressing. Human responses to these final days would vary dramatically across different cultures and communities, but there would be certain universal themes that would transcend geographical boundaries and cultural differences as our species confronted the approaching end of the world they had always known. Some people would spend these last hours in frantic activity, attempting to document or preserve some record of human civilization that might somehow survive the coming catastrophe, while others would find themselves drawn to quiet contemplation and reflection, using the time to say goodbye to loved ones or to find peace with the cosmic forces that were about to reshape their world beyond all recognition. Religious communities around the world would struggle to interpret the approaching impact within their existing theological frameworks, with some seeing the falling moon as a sign of divine judgment, while others would view it as a natural phenomenon that called for acceptance and spiritual preparation rather than fear or desperation. Prayer gatherings and meditation circles would form spontaneously in communities everywhere, bringing together people who might never have shared the same space under normal circumstances, but who now found themselves united by the universal human need to find meaning and comfort in the face of forces beyond their control or understanding. Scientists and researchers who had dedicated their careers to understanding the natural world would spend these final days making observations and measurements that would have no practical application but would represent humanity's last attempt to comprehend and document the cosmic processes that were unfolding around them. Astronomers would track the final approach of the lunar core with instruments that would soon be destroyed, while seismologists would monitor the increasing geological instability with equipment that would record Earth's final earthquakes before being overwhelmed by the ultimate seismic event that would reshape the planet's entire structure. The internet and global communication systems would experience their own form of chaos during these final hours, as the combination of electrical interference from the moon's magnetic field, disruption of satellite networks by debris, and the overloading of communication infrastructure by unprecedented volumes of traffic would create a mixture of connection and isolation that would characterize humanity's last attempts to maintain contact across the global community that had developed over centuries of technological progress. Social media platforms would become filled with messages of farewell and love, photographs of the strange skies and changing landscapes, and attempts to create some kind of permanent record of human thoughts and emotions during this extraordinary period. Children, with their remarkable capacity for adaptation and acceptance of new realities, would often display less fear and anxiety than adults during these final days, instead showing fascination and wonder at the spectacular changes taking place in their environment. Schools that remained open would find their normal curricula abandoned in favour of simple activities focused on comfort and togetherness, while families would gather to share stories and create memories that would last for whatever time remained to them, finding in human connection a source of peace and strength that no amount of scientific understanding or technological preparation could provide. Artists and musicians would create works during these final days that would attempt to capture the complex emotions and visual spectacles of a world in transition, producing paintings, songs, and poetry that would express the mixture of terror and beauty, loss and acceptance that would characterize the human response to this cosmic transformation. Some of these final works would be created with materials and techniques that reflected the changing environment around them, using volcanic ash instead of traditional pigments, or incorporating the sounds of geological upheaval into musical compositions that would serve as humanity's last artistic statements about their relationship with the natural world. As the final hours approached and the lunar core drew close enough to Earth that its gravitational effects would begin to overcome the structural integrity of Earth's crust itself, the planet would enter a state of geological chaos that would make previous changes seem insignificant by comparison. The solid ground beneath human feet would begin to crack and buckle on continental scales, creating rift valleys that would appear in minutes and mountain ranges that would rise from flat plains in the space of hours, transforming familiar landscapes into alien terrain that would exist only briefly, before being reshaped again by the next wave of tidal forces. The atmosphere itself would begin to show signs of the approaching impact, as the lunar core's gravitational field started to pull at Earth's envelope of gases with sufficient force to create atmospheric tides that would cause air pressure to fluctuate wildly and create wind patterns unlike anything in meteorological records. These atmospheric disturbances would generate their own spectacular visual effects, creating clouds and optical phenomena that would paint the sky in colours and patterns that no human being had ever witnessed, while the interaction between Earth's magnetic field and the Moon's remaining magnetic signature would generate aurora-like displays that would be visible even in broad daylight. During the final few hours before impact, time itself would seem to take on a different quality, as if the normal flow of minutes and seconds was being stretched and distorted by the same gravitational forces that were reshaping the physical world. People would find themselves caught between the urge to make every remaining moment count and the strange peace that could come from accepting that they were witnessing something far larger and more significant than any individual human life. A cosmic event that would connect their small planet to the grandest scales of universal change and transformation. The approaching impact would represent not just the end of the Moon's 4.5 billion year journey as Earth's companion, but also the conclusion of an era in planetary evolution that had allowed life to flourish in the stable environmental conditions that the Earth-Moon system had maintained for so many millions of years. Yet even as this ancient partnership prepared to end in the most spectacular collision in our solar system's recent history, there would remain something profoundly moving about the mathematical precision and natural beauty with which these cosmic forces would continue to operate, following the same fundamental laws of physics that govern everything from the smallest atomic interactions to the largest galactic structures, reminding any observers who survived to witness the aftermath that they had been privileged to see the universe itself, in the act of creating something entirely new from the materials of something very old and familiar. In the final seconds before collision, as the lunar core descended through Earth's upper atmosphere like a massive celestial meteor trailing fire and molten debris, the planet would experience what could only be described as the most violent and transformative event in its 4.5 billion year history. A cosmic convergence that would release more energy than millions of nuclear weapons, detonating simultaneously, and reshape not just the surface of our world, but its very structure, from the thin atmosphere that surrounds us to the molten core that lies thousands of miles beneath our feet. The approaching lunar remnant, now compressed and heated to temperatures that would make its surface glow like a miniature star, would create a spectacle so overwhelming that any witnesses lucky enough to survive the initial shockwave would find themselves observing something that transcended all previous human categories of natural disaster or cosmic phenomenon. The moment of actual contact between the lunar core and Earth's surface would occur with a violence that would dwarf every earthquake, volcanic eruption, and asteroid impact in our planet's geological record, releasing kinetic energy equivalent to perhaps 1 billion times the force that created the Chicxulub crater and ended the age of dinosaurs 66 million years ago. This tremendous release of energy would vaporize everything within hundreds of miles of the impact site in a fraction of a second, creating a fireball that would expand outward at speeds approaching several miles per second, instantly converting solid rock, water, and atmosphere into superheated plasma that would reach temperatures of tens of thousands of degrees, hot enough to make the surface of the sun seem cool by comparison. The initial explosion would excavate a crater so vast that it would be visible from space even through the clouds of debris and vaporized material that would immediately begin spreading across the planet's surface, a circular scar, perhaps 500 miles in diameter and dozens of miles deep, reaching through Earth's crust and into the underlying mantle layers that had remained undisturbed since the planet's formation billions of years ago. The sheer scale of this excavation would be difficult for human minds to comprehend, representing the instantaneous removal of more material than all the mining and construction projects in human history combined, creating a hole in the planet's surface so large that entire mountain ranges could disappear into its depths without trace. But the crater itself would represent only the beginning of the transformation that would sweep across Earth in the minutes and hours following impact, as seismic shockwaves traveling at the speed of sound through solid rock would race outward from the collision site, like ripples on a pond, except that these ripples would be waves of destruction carrying enough energy to level mountain ranges and trigger volcanic eruptions on the opposite side of the planet from where the impact occurred. These seismic waves would circle the globe multiple times, their energy gradually dissipating as they traveled but remaining powerful enough to cause devastating earthquakes everywhere they passed, transforming stable continental landmasses into landscapes of fractured rock and collapsed geological structures. The impact would also generate what geologists call antipodal effects, focusing seismic energy at the point on Earth's surface directly opposite the collision site, creating a secondary zone of destruction that would experience geological chaos almost as severe as the immediate impact area. If the lunar core struck somewhere in the middle of the Pacific Ocean, for example, the antipodal point might be located in Africa or Europe, where the converging seismic waves would cause the ground to buckle and fracture with such violence that entire continents would be reshaped in a matter of hours, creating new mountain ranges and rift valleys while simultaneously destroying geographical features that had existed for millions of years. The atmospheric effects of the impact would be equally dramatic and far-reaching, as the tremendous explosion would blast millions of tons of vaporized rock and debris into the upper atmosphere, creating a global cloud of dust and particles that would block sunlight and plunge the entire planet into a darkness more complete than anything experienced during the worst volcanic eruptions in Earth's history. This impact winter would begin within hours of the collision, as the expanding cloud of debris spread across the sky, transforming bright daylight into an eerie twilight that would gradually deepen into a darkness so complete that artificial lighting would be necessary, even at what should have been noon on a clear day. The debris cloud would contain not just pulverized rock and metal from the lunar core, but also vast quantities of water vapor from vaporized oceans, creating atmospheric conditions unlike anything in Earth's meteorological records. The superheated steam and dust would interact to produce precipitation patterns that would alternate between scalding rain and hailstorms of condensed rock particles, while the atmospheric chemistry would be altered by the presence of materials from the moon's interior that had never before existed in Earth's atmosphere, creating chemical reactions and compounds that would give the sky strange colors and the air itself unfamiliar odors and properties. Within the first few hours after impact, the immediate effects would begin to give way to longer-term consequences that would reshape Earth's climate and atmospheric circulation for decades or even centuries to come. The tremendous amount of heat generated by the collision would create atmospheric convection patterns unlike anything in meteorological records, generating hurricane-force winds that would circle the globe carrying debris and superheated air masses, while the disruption of normal weather systems would create temperature extremes that would make some regions uninhabitably hot, while plunging others into freezing conditions, despite the global warming effects of the impact energy. Ocean systems would be completely disrupted by the impact, with coastal areas around the world experiencing tsunamis that would make the 2004 Indian Ocean disaster seem like a gentle wave by comparison. These impact-generated tsunamis would travel across ocean basins at the speed of jet aircraft, carrying enough energy to penetrate hundreds of miles inland and completely reshape coastal geography, while the superheated water vapor in the atmosphere would eventually condense and fall as torrential rains that would create flooding on continental scales, transforming desert regions into temporary seas, while washing away river systems and lake boundaries that had remained stable for thousands of years. The impact would also have profound effects on Earth's magnetic field and rotational characteristics, as the addition of the lunar core's mass and the redistribution of material within the planet would alter the motion of molten iron in Earth's outer core that generates our protective magnetic field. This disruption could temporarily weaken or even reverse the planet's magnetic poles, leaving Earth's surface exposed to increased levels of cosmic radiation and solar wind particles that would normally be deflected away from the atmosphere, creating additional challenges for any life forms attempting to survive in the transformed environment. Plant and animal life that survived the initial shockwave and thermal effects would find themselves struggling to adapt to environmental conditions that would be unlike anything in their evolutionary history. The prolonged darkness caused by atmospheric debris would halt photosynthesis on a global scale, causing the collapse of food chains that begin with plants and algae, while the altered atmospheric chemistry would make breathing difficult or impossible for many species that had evolved to function in Earth's normal atmospheric composition. The temperature extremes, altered precipitation patterns, and increased radiation levels would create additional stresses that would challenge the survival abilities of even the most adaptable organisms. Yet even in the midst of this unprecedented destruction, there would be something undeniably magnificent about the raw power and scale of the forces at work, a demonstration of the tremendous energies that operate throughout the universe, and which had now focused their attention on our small planet in ways that would connect Earth's transformation to the same processes that create and destroy stars, shape galaxies, and drive the evolution of cosmic structures across the vast expanses of space and time. The impact would represent not just an ending, but also a beginning, the violent birth of a new kind of Earth that would carry within its restructured geology and altered atmosphere the materials and energy signatures of its ancient lunar companion. In the days and weeks following the impact, as the initial chaos began to settle into new patterns of atmospheric circulation and geological stability, any surviving observers would witness the emergence of a planet that was both familiar and utterly alien, still recognizably Earth in its basic structure and orbital characteristics, but transformed in ways that would make it a fundamentally different world from the one that had existed before the moon's fall. The impact site itself would gradually cool and stabilize, becoming a permanent scar on the planet's surface that would serve as a monument to the cosmic event that had reshaped our world, while the global distribution of lunar materials would create new geological formations and mineral deposits that would tell the story of this extraordinary collision for millions of years to come. The surviving remnants of Earth's biosphere would begin the slow process of adaptation and recovery, with some species finding unexpected opportunities in the transformed environment, while others would face extinction in ecosystems that no longer provided the conditions they needed for survival. New ecological relationships would begin to form as the survivors learned to exploit resources and fill niches that had never existed before. The impact, creating the foundations for evolutionary processes that would eventually give rise to forms of life adapted to conditions that were uniquely Earth's, but which incorporated the legacy of our ancient lunar companion. The human response to survival in this transformed world would depend on factors ranging from geographic location during the impact to the availability of stored resources and the ability of communities to maintain social organization during the period of greatest environmental chaos. Some populations might find refuge in underground facilities or specially prepared shelters, while others would need to adapt their technologies and social structures to function in environmental conditions that would make traditional agriculture, transportation, and communication systems obsolete or impossible to maintain. But perhaps most remarkably, the impact would mark the beginning of a new chapter in Earth's relationship with the broader cosmos. As our planet absorbed and integrated the materials and energy of its ancient companion, creating a world that was no longer quite the same Earth that had orbited the Sun for billions of years, but rather something new and unique, a planet that had experienced and survived the most violent transformation possible while maintaining enough structural integrity to continue supporting the possibility of life, adaptation, and eventual recovery in forms that might be unimaginable from our current perspective, but which would represent the continuation of the extraordinary story of complexity and consciousness that had begun so many millions of years ago in the stable environment provided by the Earth-Moon system that was now ending in this spectacular cosmic convergence. The impact would thus represent not just destruction but transformation, not just ending but beginning, reminding any witnesses to this extraordinary event that they were observing the universe itself, in the act of creating something entirely new from materials that were themselves billions of years old. Following the same fundamental processes of change and adaptation that had shaped Earth's history since its formation, and which would continue to operate long after the last echoes of this cosmic collision had faded into the planet's geological memory. In the months following the impact, as the dust and debris from the cosmic collision gradually began to settle from the upper atmosphere and allow filtered sunlight to once again reach Earth's surface, the survivors of this unprecedented catastrophe would find themselves inhabiting a planet that was simultaneously familiar and utterly alien, a world that retained the basic orbital characteristics and physical structure of the Earth they had always known, while displaying transformed landscapes, altered weather patterns, and ecological systems unlike anything in the planet's long evolutionary history. This would be the beginning of what future historians might call the first year after, period of gradual adaptation and discovery during which the remnants of human civilization would slowly come to understand the full scope of the changes that had reshaped their world and begin the complex process of learning to live within environmental conditions that would challenge every assumption about agriculture, technology, and social organization that had developed over thousands of years of human cultural evolution. The most immediately obvious change would be in the quality and character of daylight itself, as the atmospheric debris from the impact continued to filter and scatter sunlight in ways that would give the sky a perpetual hazy appearance, with colors and light patterns unlike anything in human memory or artistic tradition. Sunsets and sunrises would display spectacular arrays of reds, oranges, and purples as atmospheric particles interacted with solar radiation, creating photographic opportunities and visual experiences that would inspire a new generation of artists and poets, even as they served as constant reminders of the cosmic violence that had reshaped the planet's atmosphere, transformed the very nature of weather and climate across all geographical regions. The absence of the moon from night skies would create psychological and cultural impacts that would prove as challenging for human communities as the more obvious physical changes in their environment, removing a celestial reference point that had guided human navigation, timekeeping, and spiritual practices for thousands of generations, and leaving behind skies that would seem strangely empty, despite the occasional presence of orbital debris and the enhanced visibility of stars and planets that would no longer be outshone by lunar light. Children born after the impact would grow up in a world where the very concept of moonlight, tidal cycles, and lunar calendars would seem as archaic and irrelevant as many contemporary technologies might seem to us, creating generational differences in cultural memory and astronomical awareness that would reshape human relationships with the cosmos in fundamental ways. Agricultural systems around the world would face unprecedented challenges as farmers and food producers struggled to adapt to growing seasons that no longer followed predictable patterns, soil compositions that had been altered by the global distribution of lunar materials, and climate conditions that would require the development of entirely new approaches to crop selection, planting schedules, and harvest timing. Traditional crops that had been cultivated for centuries might fail completely in the transformed soil and atmospheric conditions, while others might unexpectedly thrive in environments that contain mineral compositions and nutrient balances unlike anything in agricultural history, creating opportunities for experimental farming techniques and the development of hybrid varieties that could exploit the unique characteristics of the post-impact Earth. The redistribution of water across the planet's surface would create new rivers, lakes, and wetland systems, while simultaneously causing the disappearance of familiar bodies of water that had defined regional geography and human settlement patterns for thousands of years. Coastal communities that had survived the initial tsunamis would find themselves dealing with permanently altered shorelines and sea levels, requiring massive engineering projects and social adaptations to maintain access to marine resources and transportation networks, while inland areas might discover new water sources or face drought conditions that would force entire populations to relocate and establish new forms of community organization. Underground aquifer systems that had provided fresh water for major population centers might be contaminated, disrupted, or completely destroyed by the seismic effects of the impact, creating water scarcity challenges that would require innovative technological solutions and unprecedented levels of cooperation between communities that had previously competed for scarce resources. The development of new water purification technologies, rainwater collection systems, and efficient distribution networks would become essential for human survival, while the altered precipitation patterns caused by atmospheric debris would create both opportunities and challenges for regions attempting to maintain sustainable water supplies. Wildlife populations that had managed to survive the immediate impact effects would begin the slow process of adaptation to ecosystems that had been fundamentally altered by changes in plant communities, water availability, and atmospheric conditions, creating new predator-prey relationships and ecological niches that would drive evolutionary processes at accelerated rates. Some species would find unexpected advantages in the transformed environment, expanding their ranges and increasing their populations in ways that would create entirely new patterns of biodiversity, while others would face extinction pressures that would require human intervention and conservation efforts to prevent the permanent loss of genetic heritage that had taken millions of years to develop. Marine ecosystems would face particular challenges as ocean chemistry continued to adjust to the massive inputs of lunar material and vaporized terrestrial rocks that had been distributed throughout the world's water systems during the impact, creating pH changes, temperature variations, and chemical compositions that would affect everything from microscopic plankton to the largest marine mammals. Coral reefs that had survived the initial thermal shock and tsunami effects would need to adapt to water conditions unlike anything in their evolutionary history, while fish populations would face disrupted migration patterns, altered food sources, and breeding conditions that would require remarkable resilience and adaptability to survive in the long term. Human communities would develop new forms of social organization and technological innovation as they learned to exploit resources and opportunities that had not existed before the impact, discovering mineral deposits exposed by the massive excavation of the impact crater, developing construction techniques that could utilize the unique properties of materials created by the cosmic collision, and creating communication and transportation networks that could function effectively in environmental conditions that would make many traditional technologies obsolete or inefficient. Underground communities might become more common as surface conditions remained challenging, while new architectural approaches would emerge to deal with the altered atmospheric conditions and weather patterns that would characterize the post-impact world. The scientific community would find itself with unprecedented opportunities to study planetary processes and cosmic materials that had never before been accessible to terrestrial research, as the impact would have brought samples of the Moon's deep interior to Earth's surface and created geological formations that would provide insights into planetary formation and evolution that could revolutionize understanding of solar system development. New fields of study would emerge as researchers attempted to catalogue and understand the thousands of new mineral compounds and rock formations created by the extreme pressures and temperatures of the cosmic collision, while atmospheric scientists would work to develop climate models that could account for environmental conditions that had no precedent in Earth's meteorological history. Educational systems would need to be completely redesigned to prepare new generations for life, in a world where traditional knowledge about astronomy, geography, climate, and natural history would be only partially relevant, requiring the development of new curricula that could combine essential historical knowledge with practical skills for survival and success in the transformed environment. Children would learn to navigate using star patterns that were no longer obscured by moonlight, to interpret weather signs that reflected atmospheric conditions unlike anything in previous human experience, and to understand ecological relationships that were still in the process of formation as species continued to adapt to their altered environment. Medical and health systems would face new challenges as researchers worked to understand the long-term effects of altered atmospheric chemistry, increased radiation exposure, and dietary changes resulting from the transformation of agricultural systems and the introduction of new mineral compositions into food and water supplies. Some of these changes might prove beneficial, as the unique combination of lunar and terrestrial materials could create nutritional opportunities that had never existed before, while others would require the development of new treatments and preventive measures to address health conditions that had no precedent in medical history. Religious and philosophical communities would struggle to integrate the cosmic impact into existing theological and spiritual frameworks, with some interpreting the event as a sign of divine intervention or cosmic significance, while others would view it as a natural phenomenon that required new approaches to understanding humanity's place in a universe that had demonstrated its capacity for sudden and dramatic transformation. New spiritual practices and belief systems might emerge that incorporated the reality of life on a planet that had absorbed and integrated the materials of its ancient celestial companion, creating forms of cosmic consciousness and astronomical awareness that would be unique to the post-impact generations. The economic and political structures of human civilization would undergo fundamental transformations as communities adapted to resource distributions, environmental conditions, and social challenges that would make many traditional forms of governance and economic exchange obsolete or impractical. New forms of cooperation and mutual aid would emerge as communities recognized their interdependence in the face of environmental challenges that no single group could address independently. While innovative approaches to resource sharing, technological development, and social organization would be required to maintain the complex systems that modern civilization depends upon for survival and prosperity. Yet through all of these adaptations and challenges, through the daily work of learning to live in a world that was both home and alien environment, there would remain something profoundly moving about the resilience and creativity of life itself. The way that human communities and natural ecosystems would find new forms of beauty and meaning in conditions that had initially seemed like pure destruction and chaos. The first year after the impact would mark the beginning of a new chapter in Earth's story, a period of transformation and adaptation that would demonstrate the remarkable capacity of life to not just survive but flourish in circumstances that would have seemed impossible from the perspective of the pre-impact world, creating new forms of complexity, consciousness, and connection that would carry forward the ancient legacy of life on Earth, while opening possibilities for development and evolution that could never have existed without the cosmic convergence that had brought the Moon home to the planet from which it had originally formed so many billions of years ago. As the second and third years after the impact unfolded across the transformed planet, the survivors of the cosmic collision would begin to witness something truly extraordinary. Emerging from the chaos and destruction that had initially seemed to herald only endings and loss, as life itself began to demonstrate its remarkable capacity not merely to endure in the face of unprecedented change, but to actively evolve and adapt in ways that would create entirely new forms of beauty, complexity, and ecological relationship that had never existed in all of Earth's long biological history. This period, which future naturalists might call the Great Adaptation, would mark the beginning of evolutionary processes, operating at speeds and scales that would challenge every assumption about the pace of biological change, driven by environmental pressures so intense and selection forces so powerful that species would begin to exhibit visible adaptations within generations, rather than the millennia that such changes had traditionally required. The most dramatic examples of rapid evolution would appear first among the simplest organisms, the bacteria and microorganisms that form the foundation of all terrestrial ecosystems, and which possess the genetic flexibility to respond quickly to environmental changes that would overwhelm more complex life forms. These microscopic pioneers would begin to develop metabolic pathways that could process and utilize the exotic mineral compounds created by the fusion of lunar and terrestrial materials during the impact, essentially learning to extract energy and nutrients from chemical combinations that had never before existed on Earth's surface, creating entirely new biochemical cycles that would gradually transform soil composition and atmospheric chemistry in ways that would make the planet increasingly hospitable to more complex forms of life. Plant communities around the world would begin to show signs of remarkable adaptation as root systems learned to exploit the unique mineral compositions of post-impact soils, developing symbiotic relationships with the new bacterial communities and creating hybrid forms that combine the genetic heritage of traditional terrestrial plants with biochemical innovations that allowed them to thrive in atmospheric conditions that would have been toxic to their pre-impact ancestors. Some of these botanical pioneers would develop leaves and photosynthetic systems that could function effectively in the altered spectrum of sunlight that filtered through atmospheric debris, while others would evolve root networks of unprecedented complexity and extent, creating underground communication and resource-sharing systems that would span entire continents and coordinate plant community responses to environmental changes with a sophistication that would approach the complexity of nervous systems in higher organisms. The absence of traditional tidal cycles would drive coastal marine communities to develop entirely new reproductive and feeding strategies, as species that had depended on predictable tidal rhythms for millions of years found themselves forced to adapt to ocean conditions that fluctuated according to atmospheric pressure changes, seasonal temperature variations, and the complex interactions between lunar debris patterns and underwater current systems. Some marine species would begin to develop internal biological clocks that could anticipate and respond to these new environmental rhythms, while others would evolve more flexible life cycles that could take advantage of unpredictable changes in water chemistry and temperature to exploit resources and opportunities that appeared suddenly and disappeared just as quickly. Among terrestrial animal populations, the most remarkable adaptations would appear in species that had traditionally relied on lunar cycles for navigation, mating, and seasonal behavior patterns. As these creatures developed new sensory capabilities and behavioral strategies that could function effectively in a world where the traditional celestial reference points had been replaced by constantly shifting patterns of orbital debris and enhanced stellar visibility. Migratory birds would begin to evolve, magnetic sensing organs of unprecedented sensitivity and precision, allowing them to navigate using Earth's altered magnetic field and the new electromagnetic signatures created by the distribution of lunar materials throughout the planet's crust, while nocturnal mammals would develop enhanced visual systems that could function effectively in the deeper darkness of moonless nights, while simultaneously taking advantage of the occasional bright periods created by meteor showers and burning debris. Insect communities, with their rapid reproductive cycles and genetic plasticity, become living laboratories for evolutionary experimentation, as they adapted to plant communities that were themselves undergoing rapid change, developing new feeding strategies, pollination techniques, and social behaviors that would create ecological relationships unlike anything in the fossil record. Some insect species would begin to exhibit behaviors that suggested primitive forms of agriculture, cultivating specific bacterial communities and fungal networks that could break down the exotic materials created by the impact and convert them into nutrients that could support larger ecological communities, essentially becoming the ecosystem engineers that would prepare the transformed planet for more complex forms of life. Human communities scattered across the post-impact world would find themselves becoming unwitting participants in their own evolutionary processes, as environmental pressures and resource constraints favored individuals and groups with specific physical and cognitive traits that enhanced survival in the transformed environment. While human evolution operates on much longer timescales than other species, the extreme environmental pressures and small population sizes in many post-impact communities would create conditions that could accelerate genetic changes, particularly in traits related to radiation resistance, respiratory efficiency in altered atmospheric conditions, and digestive capabilities that could extract nutrients from food sources that had been fundamentally changed by the incorporation of lunar materials into terrestrial ecosystems. More immediately visible would be the cultural and technological evolution of human societies. As communities developed new forms of knowledge, social organization, and technological innovation that were specifically adapted to the challenges and opportunities of the post-impact world, languages would begin to incorporate new vocabulary and conceptual frameworks needed to describe environmental conditions, astronomical phenomena, and ecological relationships that had never existed before, while artistic traditions would evolve to capture and express the visual experiences and emotional responses associated with life. In a world where the sky itself had become a constantly changing canvas of colors, patterns, and celestial displays unlike anything in previous human cultural memory, educational systems would develop entirely new pedagogical approaches that combine traditional human knowledge with practical skills and theoretical understanding needed to function effectively in environmental conditions that had no historical precedent, creating generations of humans whose intellectual development would be shaped by direct experience with evolutionary processes, geological transformation, and ecological adaptation occurring at speeds and scales that would make them uniquely qualified to understand and participate in the ongoing planetary transformation that was reshaping their world with each passing year. The development of new technologies would accelerate as communities learned to exploit the unique properties of materials created by the cosmic collision, discovering construction techniques, energy systems, and manufacturing processes that could utilize the exotic mineral combinations and altered chemical environments that characterized the post-impact Earth. Some of these innovations would involve learning to work with materials that exhibited properties unlike anything in traditional terrestrial chemistry, while others would focus on developing biological technologies that could harness the rapid evolutionary processes occurring in plant and microbial communities to create living systems that could perform functions traditionally handled by mechanical devices. Medical and health sciences would undergo revolutionary changes as researchers developed treatments and preventive measures that could address both the challenges and opportunities created by life in the transformed environment, discovering that some of the atmospheric and dietary changes that had initially seemed threatening actually provided protection against diseases and genetic disorders that had plagued humanity for millennia, while simultaneously developing new approaches to maintaining health and cognitive function in environmental conditions that placed unprecedented demands on human physiology and psychology. underground communities that had developed in response to challenging surface conditions would begin to create subterranean ecosystems of remarkable complexity and beauty. Learning to cultivate plant and animal communities in artificial environments that combine the best features of traditional terrestrial habitats with innovations made possible by the unique materials and energy sources available in the post-impact world. These underground civilizations would develop their own forms of architecture, agriculture, and social organization that would be specifically adapted to three-dimensional living spaces and closed-loop ecological systems, creating cultural innovations that would provide valuable models for human communities, both on the transformed Earth and potentially in future space exploration and colonization efforts. Scientific research communities would find themselves with unprecedented opportunities to study evolutionary processes in real time, documenting and analyzing biological adaptations occurring at speeds that would allow individual researchers to observe and measure genetic changes that would normally require multiple generations of scientists to detect and understand. This acceleration of evolutionary research would lead to fundamental advances in understanding the mechanisms of adaptation, the relationship between environmental pressure and genetic change, and the role of cooperation and symbiosis in creating new forms of biological complexity that could respond effectively to environmental challenges that no individual organism could address independently. Religious and philosophical communities would develop new forms of spiritual practice and intellectual inquiry that incorporated the direct experience of living in a world where the traditional boundaries between destruction and creation, ending and beginning, chaos and order were being constantly redefined by ongoing processes of planetary transformation and biological adaptation. These new spiritual frameworks would often emphasize themes of interconnection, resilience, and the creative potential inherent in apparent destruction, drawing on direct observation of ecological recovery and evolutionary innovation to develop theological and philosophical perspectives that could find meaning and purpose in the midst of unprecedented change and uncertainty. The children born into this transformed world would represent the first generation of humans whose entire cognitive and emotional development would occur within environmental conditions that had no precedent in human evolutionary history, creating forms of consciousness and ways of understanding the natural world that would be uniquely adapted to life on a planet that was still actively integrating the materials and energy of its former celestial companion. These children would grow up with intuitive understanding of evolutionary processes, ecological adaptation, and cosmic forces that would enable them to participate in the ongoing transformation of their world with creativity and insight that would be impossible for previous generations who had developed their understanding of nature within the relatively stable conditions that had characterized Earth during the billions of years of the Earth-Moon partnership. As the third year after impact drew to a close, observers of these remarkable transformations would begin to recognize that they were witnessing not just the recovery of life from a cosmic catastrophe, but the emergence of entirely new forms of biological and cultural complexity that represented genuine evolutionary innovations rather than simple adaptations of existing patterns to changed conditions. The post-impact Earth was becoming something genuinely new in the history of life in our solar system. A planet that had absorbed and integrated the materials of its ancient companion to create possibilities for biological, technological, and cultural development that could never have existed within the stable but ultimately limited conditions that had characterized the pre-impact world, demonstrating once again the remarkable capacity of life to transform apparent endings into extraordinary beginnings, and to find in the most challenging circumstances the raw materials for creating forms of beauty, complexity, and meaning that exceed anything that had come before. As the fifth and sixth years after the impact unfolded across the transformed Earth, those who had survived the cosmic collision and adapted to life in the post-impact world would begin to notice something extraordinary happening in the night skies above them. A gradual but unmistakable change in the orbital patterns of the debris that had once formed Earth's temporary ring system, and which was now beginning to coalesce and reorganize itself according to gravitational forces and cosmic mechanics that would ultimately give birth to entirely new celestial companions for our transformed planet. This period, which future astronomers might call the Great Coalescence, would mark the beginning of a process that would take decades or even centuries to complete, but which would eventually restore to Earth's night skies a sense of celestial partnership and astronomical rhythm that had been lost when the moon fell from the heavens and merged with the planet it had orbited for so many billions of years. The process would begin, slowly and subtly, as the countless fragments of lunar material that had been scattered into various orbital paths around Earth during the impact, and its aftermath began to experience the inexorable pull of gravitational attraction, drawing together into increasingly dense clusters that would gradually merge and accumulate mass, as smaller particles collided with larger ones and stuck together through processes of electrostatic attraction, chemical bonding, and simple gravitational adhesion. These growing aggregations of debris would initially appear as slightly brighter patches in the ring system, concentrations of material that would become visible to careful observers as they reflected sunlight more intensely than the surrounding field of smaller particles and dust. Over the course of months and years, these accumulation zones would continue to grow and consolidate, sweeping up additional material from their orbital neighborhoods and gradually clearing distinct paths through the debris field, as their increasing gravitational influence captured and absorbed particles that had previously followed independent trajectories around Earth. The largest of these growing bodies would begin to exhibit the characteristics of genuine celestial objects, developing their own internal structure and surface features as the constant accumulation of new material compressed and heated their cores, creating conditions that would lead to geological processes and mineral formations unlike anything that had existed in the original moon. The formation of these new moons would create spectacular visual displays for observers on Earth's surface, as the consolidation process would generate frequent collisions between large fragments that would create brilliant flashes of light, visible even during daylight hours, while the gravitational interactions between the growing bodies would cause dramatic changes in their orbital velocities and trajectories that would make the night sky a constantly changing theatre of celestial motion and astronomical drama. Some of these proto-moons would merge together in slow-motion collisions that would take place over periods of days or weeks, creating extended light shows as the enormous energies involved in these mergers would heat the colliding materials to incandescence and generate spectacular auroras and electromagnetic displays that would paint the Earth's atmosphere in colours and patterns unlike anything in the historical record. The largest of these new celestial bodies would eventually achieve sufficient mass and structural integrity to begin influencing Earth's tidal systems once again, though the patterns they would create would be far more complex and unpredictable than the simple twice-daily rhythm that had characterized the original Earth-Moon relationship. With multiple smaller moons orbiting at different distances and velocities, Earth's oceans would experience a complicated symphony of tidal influences that would create water movements and coastal patterns of extraordinary complexity and beauty, with some regions experiencing multiple high and low tides each day, while others would see extended periods of stable water levels, followed by dramatic surges that would arrive without the predictable timing that had once allowed coastal communities to plan their activities around tidal schedules. These new tidal patterns would drive another wave of evolutionary adaptation among marine species that had only recently adapted to life without traditional tidal cycles, forcing coastal ecosystems to develop even greater flexibility and resilience as they learned to cope with water level changes that followed, mathematical patterns too complex for most organisms to anticipate or prepare for in advance. Some species would develop remarkable abilities to rapidly adjust their metabolism and behavior to take advantage of whatever tidal conditions happen to be occurring at any given time, while others would evolve extremely robust survival strategies that could function effectively regardless of water levels, essentially becoming amphibious in ways that would allow them to thrive, whether their coastal habitats were submerged or exposed. Human communities would find themselves once again needing to adapt their technologies and social organization to accommodate the return of significant tidal influences, but the complex and unpredictable nature of the new tidal patterns would require engineering solutions and planning strategies far more sophisticated than anything that had been necessary during the era of the single moon. Coastal cities would need to develop flexible infrastructure that could function effectively under a wide range of water level conditions, while maritime transportation would require navigation systems and scheduling approaches that could account for tidal conditions that would vary dramatically, not just from day to day but from hour to hour as the multiple moons moved through their complex orbital dance around Earth. The new moons would also begin to influence Earth's rotational stability in ways that would gradually restore some regularity to seasonal patterns and climate cycles, though the effects would be far more subtle and complex than those that had been provided by the original moon's stabilizing influence. The multiple gravitational influences would create a dynamic equilibrium that would prevent the extreme climate fluctuations that might otherwise result from Earth's altered rotational characteristics, while simultaneously introducing new forms of astronomical rhythm and environmental periodicity that would give the post-impact world its own unique seasonal patterns and natural cycles. Agricultural communities would gradually learn to work with these new astronomical influences, developing farming techniques and crop rotation strategies that could take advantage of the complex but ultimately predictable patterns created by the multiple moon system, while also maintaining the flexibility needed to adapt to the occasional irregularities and perturbations that would occur when the orbital mechanics of the new celestial system created unexpected combinations of gravitational influences. Some regions would discover that the new tidal and gravitational patterns created growing conditions that were actually superior to those that had existed before the impact, as the complex interplay of multiple celestial influences would create soil moisture patterns, atmospheric pressure variations, and microclimate effects that would enhance agricultural productivity in ways that no single moon could have achieved. The children who had been born in the years immediately following the impact would grow into adolescence and young adulthood during this period of celestial reformation, experiencing their crucial developmental years in a world where the night sky was gradually transforming from a chaotic field of debris into an organized system of multiple moons whose motions and interactions would create astronomical displays of unprecedented beauty and complexity. These young people would develop intuitive understanding of multi-body gravitational mechanics and complex astronomical rhythms that would make them uniquely qualified to serve as navigators, astronomers, and environmental scientists in the new world that was emerging from the cosmic collision that had reshaped their planet. Artists and poets would find endless inspiration in the constantly changing patterns created by the multiple moon system, as the interactions between the new celestial bodies would create combinations of light, shadow, and color that would vary not just from night to night but from hour to hour, providing visual experiences that would challenge and expand artistic traditions in ways that would lead to entirely new forms of creative expression. Musicians would compose works that attempted to capture the mathematical harmonies and rhythmic patterns created by the orbital interactions of the multiple moons, while architects would design buildings and public spaces that could take advantage of the complex lighting patterns and shadow movements created by the new celestial configuration. Scientific communities would have unprecedented opportunities to study planetary formation and celestial mechanics in real time, observing processes that normally take millions or billions of years to complete, but which were now occurring within human lifespans as the new moon system continued to evolve and stabilize. This acceleration of astronomical processes would lead to fundamental advances in understanding how planetary systems form and develop, while also providing insights into the formation of our own solar system that could never have been gained through observation of distant star systems or theoretical modeling alone. Religious and philosophical traditions would undergo profound transformations as they attempted to integrate the experience of witnessing the birth of new worlds and the formation of a completely novel celestial system that had emerged from what had initially appeared to be pure destruction and loss. Many spiritual communities would develop new cosmological frameworks that emphasized themes of renewal, transformation, and the creative potential inherent in apparent chaos, drawing on direct observation of celestial birth and planetary reformation to develop theological perspectives that could find meaning and purpose in the midst of cosmic-scale change and uncertainty. The multiple moon system would also create new possibilities for space exploration and development, as the various new celestial bodies would provide potential stepping stones for human expansion beyond Earth's surface and serve as laboratories for studying planetary geology, atmospheric development, and the conditions necessary for life to emerge and flourish in extraterrestrial environments. Some of the new moons would develop their own thin atmospheres, as volcanic activity and chemical processes released gases from their still-forming interiors, while others would remain airless but would offer valuable mineral resources and scientific opportunities that could support both research activities and eventual human settlement. As the new celestial system continued to evolve and stabilize, establishing orbital patterns and gravitational relationships that would persist for millions of years to come, observers would begin to recognize that they were witnessing not just the recovery of their planet from a cosmic catastrophe, but the birth of something entirely unprecedented in the history of our solar system. A complex planetary system with multiple large moons whose interactions would create environmental conditions, astronomical phenomena, and opportunities for biological and technological development that would be unique in their complexity and potential. The falling of the original moon had not represented an ending, but rather a transformation, a cosmic metamorphosis that had converted a simple two-body system into something far more intricate and full of possibilities for future development and exploration. The new Earth, with its multiple moons and complex tidal patterns, its hybrid ecosystems combining terrestrial and lunar materials, and its human populations adapted to rapid environmental change and astronomical complexity, would represent a genuine innovation in planetary evolution. A world that combined the accumulated wisdom and biological heritage of billions of years of Earth's history, with the materials and energy patterns of its former celestial companion, to create possibilities for life, consciousness, and cosmic exploration that could never have existed within the simpler but ultimately more limited conditions that had characterized the pre-impact world. As the 5th and 6th years after the impact unfolded across the transformed Earth, those who had survived the cosmic collision and adapted to life in the post-impact world would begin to notice something extraordinary happening in the night skies above them. A gradual but unmistakable change in the orbital patterns of the debris that had once formed Earth's temporary ring system, and which was now beginning to coalesce and reorganize itself according to gravitational forces and cosmic mechanics that would ultimately give birth to entirely new celestial companions for our transformed planet. This period, which future astronomers might call the Great Coalescence, would mark the beginning of a process that would take decades or even centuries to complete, but which would eventually restore to Earth's night skies a sense of celestial partnership and astronomical rhythm that had been lost when the moon fell from the heavens and merged with the planet it had orbited for so many billions of years. The process would begin, slowly and subtly, as the countless fragments of lunar material that had been scattered into various orbital paths around Earth during the impact, and its aftermath began to experience the inexorable pull of gravitational attraction, drawing together into increasingly dense clusters that would gradually merge and accumulate mass, as smaller particles collided with larger ones and stuck together through processes of electrostatic attraction, chemical bonding, and simple gravitational adhesion. These growing aggregations of debris would initially appear as slightly brighter patches in the ring system, concentrations of material that would become visible to careful observers as they reflected sunlight more intensely than the surrounding field of smaller particles and dust. Over the course of months and years, these accumulation zones would continue to grow and consolidate, sweeping up additional material from their orbital neighborhoods and gradually clearing distinct paths through the debris field, as their increasing gravitational influence captured and absorbed particles that had previously followed independent trajectories around Earth. The largest of these growing bodies would begin to exhibit the characteristics of genuine celestial objects, developing their own internal structure and surface features as the constant accumulation of new material compressed and heated their cores, creating conditions that would lead to geological processes and mineral formations unlike anything that had existed in the original moon. The formation of these new moons would create spectacular visual displays for observers on Earth's surface, as the consolidation process would generate frequent collisions between large fragments that would create brilliant flashes of light, visible even during daylight hours, while the gravitational interactions between the growing bodies would cause dramatic changes in their orbital velocities and trajectories that would make the night sky a constantly changing theatre of celestial motion and astronomical drama. Some of these proto-moons would merge together in slow-motion collisions that would take place over periods of days or weeks, creating extended light shows as the enormous energies involved in these mergers would heat the colliding materials to incandescence and generate spectacular auroras and electromagnetic displays that would paint the Earth's atmosphere in colours and patterns unlike anything in the historical record. The largest of these new celestial bodies would eventually achieve sufficient mass and structural integrity to begin influencing Earth's tidal systems once again, though the patterns they would create would be far more complex and unpredictable than the simple twice-daily rhythm that had characterized the original Earth-Moon relationship. With multiple smaller moons orbiting at different distances and velocities, Earth's oceans would experience a complicated symphony of tidal influences that would create water movements and coastal patterns of extraordinary complexity and beauty, with some regions experiencing multiple high and low tides each day, while others would see extended periods of stable water levels, followed by dramatic surges that would arrive without the predictable timing that had once allowed coastal communities to plan their activities around tidal schedules. These new tidal patterns would drive another wave of evolutionary adaptation among marine species that had only recently adapted to life without traditional tidal cycles, forcing coastal ecosystems to develop even greater flexibility and resilience as they learned to cope with water level changes that followed, mathematical patterns too complex for most organisms to anticipate or prepare for in advance. Some species would develop remarkable abilities to rapidly adjust their metabolism and behavior to take advantage of whatever tidal conditions happened to be occurring at any given time, while others would evolve extremely robust survival strategies that could function effectively regardless of water levels. essentially becoming amphibious in ways that would allow them to thrive, whether their coastal habitats were submerged or exposed. Human communities would find themselves once again needing to adapt their technologies and social organization to accommodate the return of significant tidal influences, but the complex and unpredictable nature of the new tidal patterns would require engineering solutions and planning strategies far more sophisticated than anything that had been necessary during the era of the single moon. Coastal cities would need to develop flexible infrastructure that could function effectively under a wide range of water level conditions, while maritime transportation would require navigation systems and scheduling approaches that could account for tidal conditions that would vary dramatically, not just from day to day but from hour to hour as the multiple moons moved through their complex orbital dance around Earth. The new moons would also begin to influence Earth's rotational stability in ways that would gradually restore some regularity to seasonal patterns and climate cycles, though the effects would be far more subtle and complex than those that had been provided by the original moon's stabilizing influence. The multiple gravitational influences would create a dynamic equilibrium that would prevent the extreme climate fluctuations that might otherwise result from Earth's altered rotational characteristics, while simultaneously introducing new forms of astronomical rhythm and environmental periodicity that would give the post-impact world its own unique seasonal patterns and natural cycles. Agricultural communities would gradually learn to work with these new astronomical influences, developing farming techniques and crop rotation strategies that could take advantage of the complex but ultimately predictable patterns created by the multiple moon system, while also maintaining the flexibility needed to adapt to the occasional irregularities and perturbations that would occur when the orbital mechanics of the new celestial system created unexpected combinations of gravitational influences. Some regions would discover that the new tidal and gravitational patterns created growing conditions that were actually superior to those that had existed before the impact, as the complex interplay of multiple celestial influences would create soil moisture patterns, atmospheric pressure variations, and microclimate effects that would enhance agricultural productivity in ways that no single moon could have achieved. The children who had been born in the years immediately following the impact would grow into adolescence and young adulthood during this period of celestial reformation, experiencing their crucial developmental years in a world where the night sky was gradually transforming from a chaotic field of debris into an organized system of multiple moons, whose motions and interactions would create astronomical displays of unprecedented beauty and complexity. These young people would develop intuitive understanding of multi-body gravitational mechanics and complex astronomical rhythms that would make them uniquely qualified to serve as navigators, astronomers, and environmental scientists in the new world that was emerging from the cosmic collision that had reshaped their planet. Artists and poets would find endless inspiration in the constantly changing patterns created by the multiple moon system, as the interactions between the new celestial bodies would create combinations of light, shadow, and color that would vary not just from night to night but from hour to hour, providing visual experiences that would challenge and expand artistic traditions in ways that would lead to entirely new forms of creative expression. Musicians would compose works that attempted to capture the mathematical harmonies and rhythmic patterns created by the orbital interactions of the multiple moons, while architects would design buildings and public spaces that could take advantage of the complex lighting patterns and shadow movements created by the new celestial configuration. Scientific communities would have unprecedented opportunities to study planetary formation and celestial mechanics in real time, observing processes that normally take millions or billions of years to complete, but which were now occurring within human lifespans as the new moon system continued to evolve and stabilize. This acceleration of astronomical processes would lead to fundamental advances in understanding how planetary systems form and develop, while also providing insights into the formation of our own solar system that could never have been gained through observation of distant star systems or theoretical modeling alone. Religious and philosophical traditions would undergo profound transformations as they attempted to integrate the experience of witnessing the birth of new worlds and the formation of a completely novel celestial system that had emerged from what had initially appeared to be pure destruction and loss. Many spiritual communities would develop new cosmological frameworks that emphasized themes of renewal, transformation, and the creative potential inherent in apparent chaos, drawing on direct observation of celestial birth and planetary reformation to develop theological perspectives that could find meaning and purpose in the midst of cosmic-scale change and uncertainty. The multiple moon system would also create new possibilities for space exploration and development, as the various new celestial bodies would provide potential stepping stones for human expansion beyond Earth's surface and serve as laboratories for studying planetary geology, atmospheric development, and the conditions necessary for life to emerge and flourish in extraterrestrial environments. Some of the new moons would develop their own thin atmospheres, as volcanic activity and chemical processes released gases from their still-forming interiors, while others would remain airless but would offer valuable mineral resources and scientific opportunities that could support both research activities and eventual human settlement. As the new celestial system continued to evolve and stabilize, establishing orbital patterns and gravitational relationships that would persist for millions of years to come, observers would begin to recognize that they were witnessing not just the recovery of their planet from a cosmic catastrophe, but the birth of something entirely unprecedented in the history of our solar system. A complex planetary system with multiple large moons whose interactions would create environmental conditions, astronomical phenomena, and opportunities for biological and technological development that would be unique in their complexity and potential. The falling of the original moon had not represented an ending, but rather a transformation, a cosmic metamorphosis that had converted a simple two-body system into something far more intricate and full of possibilities for future development and exploration. The new Earth, with its multiple moons and complex tidal patterns, its hybrid ecosystems combining terrestrial and lunar materials, and its human populations adapted to rapid environmental change and astronomical complexity, would represent a genuine innovation in planetary evolution. A world that combined the accumulated wisdom and biological heritage of billions of years of Earth's history, with the materials and energy patterns of its former celestial companion, to create possibilities for life, consciousness, and cosmic exploration that could never have existed within the simpler but ultimately more limited conditions that had characterized the pre-impact world. As we reach the end of our journey through this extraordinary tale of cosmic transformation and planetary rebirth, it becomes clear that the story of the moon's fall to Earth represents far more than a simple catastrophe followed by recovery, revealing itself instead as a profound meditation on the nature of change, adaptation, and the remarkable capacity of life to transform apparent destruction into unprecedented opportunities for growth, evolution, and the emergence of forms of beauty and complexity that could never have existed within the stable but ultimately limited conditions that had characterized our world for so many billions of years. 10 years after the impact, as the transformed Earth settled into its new rhythms and patterns, as the multiple moon system achieved greater stability, and the hybrid ecosystems found their unique balance between terrestrial heritage and lunar innovation, those who had survived and adapted to this cosmic transformation would begin to recognize that they had been privileged witnesses to something far more significant than the end of one world and the beginning of another. They would understand that they had observed the universe itself in the act of creation, demonstrating through the violence and beauty of cosmic collision the same fundamental processes that had shaped galaxies, formed star systems, and given birth to the conditions necessary for life to emerge and flourish throughout the vast expanses of space and time that constitute the cosmic environment within which all existence unfolds. The falling moon had not destroyed Earth, but had instead completed a circle that had begun billions of years earlier, when the two bodies had first separated from the same primordial materials, teaching those who witnessed its return that the apparent permanence of astronomical arrangements was itself an illusion, and that the universe operated according to principles of change, transformation, and renewal that could find creative potential in the most devastating circumstances. The children who had grown up during the decade following the impact would represent the first generation of human beings whose entire understanding of the natural world had been shaped by direct experience of planetary transformation, ecological adaptation, and astronomical reorganization occurring at speeds and scales that would make them uniquely qualified to serve as bridges between the old world that their parents remembered and the new world that was still emerging from the cosmic convergence that had reshaped their planet in ways that would influence its development for millions of years to come. These young people would carry within their consciousness an intuitive understanding of impermanence, adaptability, and the creative potential inherent in apparent chaos that would enable them to approach future challenges and opportunities with a flexibility and resilience that previous generations could never have developed within the more predictable but ultimately more limiting conditions of the pre-impact world. Their education would have encompassed not just traditional human knowledge and skills, but also practical experience with evolutionary processes, geological transformation, and astronomical mechanics that would make them the first truly cosmic generation in human history. People whose understanding of their place in the universe would be based not on theoretical knowledge, but on direct participation in the fundamental processes that shape planetary systems and drive the evolution of life throughout the cosmos. They would grow into adulthood with the confidence that comes from having witnessed the resilience of life in the face of ultimate challenges, and with the wisdom that emerges from understanding that destruction and creation are not opposite forces, but rather different aspects of the same cosmic processes that constantly reshape the universe, according to principles that operate with equal effectiveness, whether they are governing the formation of galaxies or the adaptation of individual organisms to changing environmental conditions. The scientific legacy of the Moon's fall would extend far beyond the immediate practical benefits of studying rapid evolutionary processes, exotic mineral formations, and complex astronomical mechanics in real time, ultimately revolutionizing human understanding of planetary science, evolutionary biology, and cosmic development in ways that would provide insights and capabilities that could never have been gained through traditional research methods or theoretical modeling alone. The post-impact Earth would serve as a living laboratory for studying the conditions necessary for life to emerge and flourish in extraterrestrial environments, while the multiple moon system would provide unprecedented opportunities for comparative planetary science and the development of technologies and techniques that would be essential for future space exploration and the eventual establishment of human communities beyond Earth's atmosphere. The agricultural innovations developed during the adaptation period would prove to have applications far beyond the specific challenges of farming in post-impact conditions, leading to sustainable food production techniques that could function effectively in a wide range of environmental conditions, and laying the groundwork for agricultural systems that could support human communities on other planets or in space habitats where traditional farming methods would be impossible or impractical. The hybrid ecosystems that had emerged from the combination of terrestrial and lunar materials would demonstrate new forms of ecological organization and resource utilization that could serve as models for creating self-sustaining, life support systems in environments where natural ecosystems could not develop through normal evolutionary processes. The medical and health advances that had emerged from research into the effects of altered atmospheric conditions, novel mineral compositions, and enhanced radiation exposure would lead to treatments and preventive measures that would extend human lifespan, enhance physical and cognitive capabilities, and provide protection against diseases and genetic disorders that had plagued humanity throughout its evolutionary history. Some of these advances would prove to have applications for space travel and life in extraterrestrial environments, while others would simply improve the quality of life for Earth's population by providing medical technologies and therapeutic approaches that had never been possible within the more limited chemical and biological environment of the pre-impact world. The social and cultural transformations that had occurred during the adaptation period would create new forms of human organization and cooperation that would prove to be more resilient, flexible, and effective than traditional social structures in addressing complex challenges that required unprecedented levels of coordination and mutual support across diverse communities and geographical regions. The experience of surviving and adapting to cosmic-scale environmental change would demonstrate the importance of maintaining cultural diversity, while simultaneously developing shared approaches to problem-solving and resource management, creating social innovations that would be valuable not just for life on the transformed Earth, but for any future human communities that might face the challenges of establishing civilization in new and unfamiliar environments. The artistic and cultural renaissance that had emerged from the visual and emotional experiences of life under multiple moons, in hybrid ecosystems, and amid constantly changing atmospheric and astronomical conditions, would produce forms of creative expression that would enrich human culture in ways that would extend far beyond the specific circumstances that had inspired them. The music, literature, visual arts, and architectural innovations that had developed during the post-impact period would demonstrate new possibilities for human creativity and aesthetic experience that would influence cultural development for generations to come, while also providing models for how artistic traditions could adapt and evolve in response to environmental changes and new forms of sensory experience. The spiritual and philosophical developments that had occurred as human communities struggled to find meaning and purpose in the midst of unprecedented change and uncertainty would lead to new forms of religious and philosophical understanding that could provide guidance and comfort in the face of future challenges, while simultaneously encouraging the kind of intellectual and spiritual flexibility that would be necessary for humanity to continue growing and developing as a species capable of thriving in a universe characterized by constant change and infinite possibility. Perhaps most remarkably, the post-impact world would serve as a demonstration of the principle that apparent endings often contain within them the seeds of extraordinary new beginnings, and that the universe operates according to creative principles that can transform even the most devastating circumstances into opportunities for development and evolution that exceed anything that could have been achieved within the conditions that existed before the transformation occurred. The falling moon had not destroyed the world, but had instead revealed the world's capacity for renewal and reinvention, teaching those who witnessed its transformation that life itself is far more resilient, creative, and adaptable than anyone had previously understood. The legacy of the fallen moon would thus extend far beyond the specific changes it had brought to Earth's geology, atmosphere, and biological systems, ultimately serving as a reminder that human beings live within a universe that operates according to principles of transformation and renewal that make possible forms of existence, consciousness, and creative achievement that would be impossible within static or unchanging conditions. The cosmic collision that had initially seemed to herald the end of everything familiar and reliable had instead opened doorways to possibilities that had never existed before, demonstrating that the universe itself is fundamentally creative, and that apparent destruction is often simply the preliminary stage of construction projects operating on scales so vast that their ultimate purposes and achievements can only be understood from perspectives that encompass geological timescales and cosmic spatial dimensions. As our contemplation of this extraordinary tale draws to a close, we are left with the profound understanding that the story of the moon's fall represents not just an exploration of what might happen if our celestial companion were to descend from the heavens, but rather a meditation on the fundamental nature of change itself and the remarkable capacity of life, consciousness, and creativity to find in the most challenging circumstances the raw materials for building forms of beauty, meaning, and possibility that exceed anything that had existed before the transformation began. The falling moon teaches us that we live in a universe where endings and beginnings are constantly intertwined, where destruction and creation are different aspects of the same cosmic processes, and where the apparent permanence of our familiar world is, itself a beautiful but temporary arrangement that exists within the context of forces and possibilities so vast and creative that they exceed our capacity to fully comprehend or predict their ultimate achievements. In closing, we return to that quiet place where we began our journey together, that peaceful space of contemplation and reflection, where the boundaries between the possible and the actual become permeable, and where the imagination can safely explore scenarios and possibilities that illuminate not just the mechanics of cosmic transformation, but the deeper truths about resilience, adaptation, and the extraordinary creative potential that exists within apparent chaos and destruction. The moon continues to hang peacefully in our night sky, maintaining its ancient dance with Earth and providing the stable conditions that allow life to flourish in predictable patterns. But our exploration of its hypothetical fall has revealed the remarkable truth that even the most catastrophic changes contain within them the potential for forms of beauty and possibility that could never have emerged within unchanging conditions, reminding us that we are privileged participants in a universe whose creativity and capacity for renewal exceed anything we can fully imagine or understand.